Hello and welcome back everyone. Today we're going to continue the tutorial on how to use the PlanOpSim software to simulate subwavelength structures by moving on from uniform layers to structured layers. So I'll start as before by defining a new simulation. In this case I want to simulate a diffraction grating, so I'll call that first grating. Add that. And I will be taken again to the structure page where I will start defining the substrate layer, assign its thickness to 0 nanometer, add the layer, choose the material, in this case silicon dioxide. There we go. And then I want to define on top of this substrate a grating. The first thing I want to set there is the width and the height. This will carry through no matter how many layers I define. So we'll have the width and the height assigned in this case to 500 nanometer. And then I will define the layer itself. So I will call the layer grating. I'll give it a thickness. And now the most important thing is to set the dimensions of the structure. And for that I will upload a file. In this case I will create this red square in an orange background and upload that. What the software will now try to do is look at the colors inside the image and try to match them to colors that are known in the database connected to known materials. So in this case we have the image here. Here's the side view. It recognized the orange as ytterbium, and the inner color it actually did not recognize, so that has been set to unknown. Now the colors that we made were arbitrary, and in fact we don't want to simulate an unknown material, so let's assign that. The inner square I want to set again to silicon dioxide, so I'll select that, go to the drop down list and choose silicon dioxide. There we are. Save that. And now we have to choose the second material, which was set to ytterbium, but we want to choose air instead. So let's scroll through and select air. There we go. Save that as well. And you'll see, oops, it set it to aluminum arsenide. I must have misclicked. All the way down to air. Yes, that's better. Okay, you'll notice that the image has changed. So before we had a red square in an orange background, we now have the light green indicating silicon dioxide and this color indicating air. And in our layer stack we have two layers, one called substrate, one called grating. I still have to create a new layer on top for the incident light. I'll call that one air and give it a thickness of 0. Add that one as well. Set it to the proper material, in this case again air. Voila. Save that. And now we have 3 layers. An air layer on top, a grating layer and a substrate layer. Then I'll go on defining the rest of the simulation. So I'll set the incident light in the same way as before. I'll set the simulation settings. Now as soon as we have a structured layer inside, it's important that the number of diffraction orders is high enough to actually simulate with sufficient precision. So I'll increase the setting for maximum diffraction orders to 2 by 2. And I'll also add a wavelength sweep to my simulation. So I'll add a sweep parameter called wavelength, which will be varied linearly from 500 to 600 with step size 10. And I'll save that. still need to assign the wavelength to one of the parameters. I'll assign it to the wavelength of the incident light. I'll type equal sign wavelength. There we go. Voila. That defines our simulation. So all that remains is to go to the Simulate tab here. And once it's loaded, click Launch Simulation. Voila. And now the server will take care of the work, simulate this for us, and afterwards we can take a look at the result in the same way as before, and we'll do that in the next video. Bye bye everyone.